So we talked about APIs. I think we covered APIs all we need. This video is going to go over starting week 4. So the idea today is we're going to cover NumPy and SciPy and what Anaconda is and all of that. And then on Tuesday, we're going to cover mini project. So how to set up a Git project, how to work on your first real homework assignment. So that'll all be Tuesday and Thursday of next week. So to get started on NumPy here today, there again, just like we've done in the past, I like to use the documentation pages for that. So you can get this out of Blackboard, and you can talk about what NumPy is. So NumPy and SciPy are really just scientific packages within Python that's meant for dealing with mathematical shape manipulation, sorting, selecting, any kind of mathematical computation stuff that you want to do. Will probably take advantage of either NumPy or SciPy. All right. At the core of a NumPy is what's called an ND array object that's going to encapsulate an nth dimensional array as homogeneous data types with operations being performed in compiling code. So the big thing to remember with NumPy is they have a fixed size at creation. So unlike Python lists, which can grow dynamically, once you create an ND array, it is that array, right? You have to either create a new one and delete the original one if you want to resize it or rebuild it. Because of that, NumPy arrays are significantly faster than Python lists. When you're doing computational data or operations around them, they operate at near, C+ speeds kind of thing. Very, very fast. All right. So documentation over here on the left. Couple things about documentation. When you get to these kind of API documentation, if you guys haven't played with them, up here in the upper right is where you can usually drop down a version code. Some websites will do things a little bit differently. So always look up here and make sure you're on the latest stable release when you're looking at documentation. For installing NumPy and such, for us, what we will do is use pip install NumPy, right? Okay. Right into a package, pretty easy. This up here is talking about Anaconda, which I will bounce and talk about real quick. So Anaconda is a particular distribution of Python that has a bunch of different packages already installed in it. We will not install it in here. So if you guys watch the old video, it actually shows you how to install it and do all that kind of stuff. We won't do that in this class because you don't really need to do that. Trying to get down here where it actually shows you, which is what I wanted. There we go. So Anaconda, again, is really meant for scientific visuals. It has matplotlib and all that kind of stuff built in. For whatever reason, they're not showing it like they used to in the video I had before. Okay, so for like visualization, they're going to use matplotlib, Seaborn, Plotly, GraphViz. These are all packages installed. Numerical stuff, you're going to have NumPy automatically, SciPy in there for dealing with scientific stuff, like you can see here. Pandas, all this other stuff. So it's a collection of everything you would need to do any kind of data processing. What this means is for you computer science students that would want to get a specific distro, this would have everything installed, and you can use Conda.
Oh, that's handy.
With Conda itself, when you go to install that, you use the word Conda install as opposed to pip install. So the package manager for Anaconda is called Conda. You can Conda install NumPy or do whatever you want.
So you would install Anaconda, and then Conda kind of replaces pip when you're installing things.
Right. It installs even your basic Python. It's a very specific version of Python that's meant with all these individual packages that have been tried and tested.
So can you run just regular Python and Anaconda side by side?
Absolutely.
Oh, handy.
Yep. And same way in PyCharm, which we'll be playing with in here. So PyCharm, let's load that up real quick and I'll show you how Conda works in there. So again, you can install the Anaconda distribution. It just includes everything already set up for scientific computing and data science, data analytics, that kind of stuff. And here, if you were to create a new project, file, new project, you could do something like scientific over here and notice that it changes the default environment to Conda, right? So it's just going to automatically include all those packages. You could pick which version you wanted it to run. It would download and run that. Now notice it says Conda executable path is empty. You have to install Anaconda on your system. Then you could use this so that you could use that interpreter package.
So can you change it from Conda just back to regular Python? I mean, it's probably just easier to use Conda.
Right. So Conda, if you're going to be using all this in a data science project, it might be easier just to use Conda right off the bat because it has all the packages. For this class, we're just going to be using pure Python and installing the packages we need.
Okay.
So when we install them, it's obviously going to have requirements to install the other packages along the way. So that's the reason I say you don't necessarily need to install Conda, but I want to expose you to it because if you're doing scientific computations or something,
yeah,
it's easier to use Anaconda at that point. All right. So going back to NumPy, again, for what we're going to use is just pip install NumPy for that. Now, when you actually import that into your packages, a lot of times that is going to be installed in a different way. So we're going to go to quick start here. That's a great place to get the basics out of it. So when you guys are working with arrays, you're going to see arrays like this, which is essentially a list of lists, right? So this first list is just the overall arcing one. This one here is going to have a set of data. The second one is going to have a second set of data. This would be like axes on a graph, right? So the first list is going to be your x-axis, the second axis, or the second one's going to be your second list accordingly, right? Those are in a NumPy array, which is called an ND array. Works very similar to the arrays that you guys are using in other languages, but they're very, very optimized for what they're doing. All right. In Python, they have arrays in there, but they're one-dimensional arrays. These allow you to do 1, 2, and 3-dimensional arrays on up, right? Depending on how you want to do that. So again, I like using the documentation so you guys get a chance to play with it. If you pull up PyCharm here, let me get you a new project here. Let's just do this. We're going to call this project playing with NumPy. Doesn't matter what you call it, right? And we're going to start with a very basic Python interpreter coming into the project. So to get started with NumPy, we're going to go out here to our terminal. And you can make sure you're in the virtual environment. Pip install NumPy. Now it's going to install a bunch of extra requirements for NumPy inside of there, but that's what we want to do. Get it up and running. There we go. And if we come out here, this is the code. Now, if you guys have never read documentation before, when you have these 3 greater than signs, that just means that this is code that you're typing in. This is showing the output of it, right? It's just like the command line interpreter when you guys are actually using the interpreter itself. So if we were to play with this example that they give us, just pull it over here side by side, get this out of the way, and go to our Python console. First thing we need to do is import NumPy. So we do import NumPy as NP. Now this import NumPy as NP, notice that we use as, which we've never used really before. That is so that you can set the own title of what you want. So instead of having to say NumPy dot whatever, it's now just NP dot whatever. That is an industry standard with some packages. And so in this class, if you're using an industry package, use the industry standard for importing that in. Don't just use import NumPy.
Which that would be in the documentation.
Yes. Yep. The other reason to use that industry standard is if you go out and check out other GitHub projects, they're probably using the industry standard as well. If you change it to just import NumPy, then you got to change all your code to go from NP dot to NumPy dot something. Almost every package we use is going to have import as something else, right? So now that we've imported that in, we can do something like A equals NP arrange, right? And this is going to use 15 dot reshape, and all this is doing is building the NumPy array for us.
So I'm guessing that takes 15 items and reshapes them into 3 sets of 5.
Yes. Yep. Let's see here. What did I miss? Let me just type this back in. I might have not got this imported correctly. There we go. And if we look at the A object, because we're using the interactive shell here, we can see that it created a 3-dimensional array, right? It wanted 5 characters going between there, and it's going from 0 to 5. That's what the arrange is doing, is adding numbers 0 through 5, or 15, sorry, and through there. All right. If we look at its shape, which just means we're getting back the dimensions that are through there, we again see that it's going from 3 to 5. You can look at the dim, the shape, all of this gets you set up. It's mostly this array creation is what you guys want to pay attention to. All right. For the purposes of this class, this will allow you to print the different arrays. So if you use reshape, you can sort it to where you can see it really nice. Let's see here. What's the other key piece that's in this? There's a bunch of different functions. You can use slicing and indexing, just like we would normally do with arrays or lists. So you can do those same functions inside of here. Shape manipulation, that's not really what we want. There's a ton of things about NumPy that I'm not necessarily covering in this class. I'm just exposing you to what NumPy is. The reason for that is most of what you guys will be using is NumPy will be imported as a package, and whatever program you're using is using this in the background, right? Unless you're doing hard data science, you're probably not writing your own arrays and everything else inside of there.
So, Jason.
Yeah.
So is this different than a set or a list? I mean.
Yes. Yeah. So again, a NumPy array is similar to a list, but is computationally faster and does not have the same properties as a list. Let's see here. So the one I really wanted to show you is wherever that's a histogram. That's not quite what I'm looking for. My matplot go. All right, if you look over here on the left, you can see the fundamentals on how to create your arrays, broadcast, data types, etc. MATLAB is a little bit different. So MATLAB is its own software suite that you guys would use in data science if you guys are playing through there. All right. If we click on these tutorials, we should be able to do linear algebra. Does this actually show us? It's doing SciPy on the different images. Where is my plot? There we go. All right, give me a second here to find the right one. There we go. This is what we need to know. So what this will allow us to do is play with matplotlib, right? So we will need to install that. But when you import matplotlib, it will be matplotlib.pyplot as PLT. And again, this is what you're typically going to see out in industry. So you'll want to do that. There is this concept called Jupyter Notebooks. Does anybody know what that is or heard of them? Okay, so Jupyter Notebooks basically is a Python distribution that has all this kind of matplotlib stuff built in, so you can do nice charting and data analysis and all that kind of stuff interactively as you're pulling through the data. It's nothing that you can't already do in Python in general. So for us, we're going to import matplotlib as pylib. That's going to die because we need to install it. So packages or terminal, let's do terminal. Pip install matplotlib. Now, when you guys set your projects, and again, we're going to talk about this next week of creating the get ignore file, the readme file, the requirements.txt file, that kind of stuff. All of that will be important because if they update matplotlib and it works for you this week, but then you update the software or I check it out, it will break.
Yeah.
All right. We actually had that last year in this class. They happened to do an upgrade right between the time somebody did their homework assignment and when it was due, and it broke everything. Everybody's homework assignment was broken. So that's where pip freeze and all that kind of stuff, which we're all going to talk about on Tuesday. Okay, so now that we have matplotlib installed, we would start with an array that looks like this here. And for this, I'm just going to create this basic package over here. Let's do that. Let's get this out of the way so you guys can see. Let's do our import up at the top. All right. So what this is doing is we're going to create a NumPy array, right? It's a single dimensional array. We have all these different numbers in between there. That would be our X points as we're going to plot these across over the total number of points that we have, right? So the total number of points is X. Y is the value of those individual pieces, right? What's nice about doing this, if you click over here on the right-hand side, you have called SciView with PyCharm, and this allows you to see this data. So when we run it at the console, we can actually see it here, and we can see our charts pop up automatically as well. All right. So when you're playing in this view, you'll want to turn on SciView over here on the right-hand side. Next, we will need to actually show this. So we'll do plt dot show, or we want to plot it first, and then we need to do the show. So plot A, which is just the name of the array we created, and then plt dot show, which allows us to actually see it. So if we run this little script, it comes up over here. What did I have here? MP. Oops, I forgot to import NumPy. So import NumPy as NP.
You said it's preferred to do as NP.
Yes. Yeah. For industry standard, you want to plug those in. All right. So if I hit play and everything goes well, you can see that it automatically charted that data up here to the right.
Okay.
Right. So again, as those numbers went from 0 to 12, that's the different numbers, are the indexes as we go across, right? And then the actual value is what got charted in that graph going up. We look at the data, we could actually interpret that at the Python console, etc. So this is a really basic array of what you guys would want to see. If you want linear arrays, you could print those in this fashion. So notice you're doing linear array for this data. This is another line. And then if you want to plot that, you use plot and you specifically say what X is and what Y is, right? So you may have two different arrays, one defined as X, one defined as Y. When you plot those, and then you can say that you want a purple or O's or whatever you want to plot that line out. So there's a whole lot of extra things you can do when you go to plot.
Mhm.
Right?
Can you go back up to the first plot, that one?
Yep.
So would you say that since it was just a single, I don't know, scroll up a little bit more. Yeah, right there.
Yep.
So all those numbers are just the vertical or the horizontal axis? Or?
Yeah, those are all your Y values going across. And then the indexes in this case are your X. Because we only specified a one-dimensional array here, that's the reason that they went in that fashion. If you want to specifically say what you want to use for X values and Y values, then you would do something like this, where you create an array for the X, create an array for the Y, and then when you go to plot, you tell it you want X, Y, and in this case, purple does a line plot kind of thing. So for example, if we have, this is say X, right? And then we take this line here and we say this is Y. And then we plot X comma Y comma and say purple. Show it. You'll see that it does this linear graph going up. The reason it's doing that is we're using the same X and Y values, right? So it just plotted them going on up. If we were to change these numbers and give different ones, say 5, 6, 3, 9, 2. Something outrageous like 88 in there, and we actually plot it, you would see that it obviously doesn't look pretty because my data is going everywhere, right?
Mm-hmm.
So you would obviously have uniform data as it was going through for X and Y coordinates as you go through.
So how was that? I guess, sorry, I'm like stuck. Well, how was the first example then, where you just had the one row?
Just the A equals,
Yeah.
looks like that. So here you're just doing A equals this, and we just tell it to plot the one line A. In this case, it's going to use the index for your X's, and it's going to use these values as your Y going up.
Oh, that's right. Okay, the index being 0 through
15.
Oh, okay.
Yeah.
I
Or in
didn't
this
catch.
case, 0 through 12.
That's what I didn't catch. Okay.
Yeah.
Are you able to like put a title on the axis on the graph at all?
Great question. That's actually the next thing we're going to look at. So you can also do like 3D figures. So as you can see here, you can do 3D projections of different data that you want to spit out and kind of go through there. All right. What we want to look at is what you were just talking about, which was being able to use matplot. All right, you go out here to matplotlib, you can do a search, you can figure out how to do any one of these. In this case, we just want to plotlib, right? And if you look at these, this time we're going to plot 1, 2, 3 and just go out, right? We're not using a NumPy array, but we would want to in our class. But if we just use plot, and then we have these numbers 1, 2, 3, 4, you can see that we're using 1, 2, 3 going over, registering that we are what? Indexes 0, 1, 2, 3 going across. And then our values are the 1, 2, 3, 4 going up. That's why you see it starts at 1, 0 here. Okay. Y label is going to be some numbers that allows us to set that here. So for your answer, it would be X label, which would allow us to set an X label going across.
Gotcha.
So for example, if we came over here and we set, sorry, I clicked on the wrong one here. So before we do a show, we would have something like plt.x label. And our X label in this case is going to be the word indexes. And our plt.y label would be something like values, whatever it is, right? And then we hit show, we plot it, and now we have indexes and values over here. All right. So great question on how to do that. If we had a 2-dimensional array like this, that allows us to no longer use indexes. We're now using the values of these as they go through. So this becomes our X, this becomes our Y. If we had a 3-dimensional, then we would have 3 lines going through there. For example, what you see here. Now you may want to plot in different styles, right? We don't want to do line. If you want to do specific axes, you can justify that here, right? You can do like here, it's doing /B. That will do a blue line. You can do dots going up. All of that is in the documentation for Matplotlib. So in the homework assignment next week. So like here, you can see that we wanted to use the first one as red dashes. Then we wanted to use blue squares. And then we wanted green triangles going up to make these graphs. You can adjust that with the plot and set the different settings go through there. If you're in PyCharm, and we go to say plot question, remember that it's going to tell you all the different values you can set up here. All right. And if you need more information on that, you can always go in and do the documentation for Matplotlib and see what's in there. So keyword strings, if you wanted to print that out, like you can do here, bigger size dots based on the size it goes through. You may do charting or grouping of the different information. These are all scatter plots and different styles. The idea is that you want to go in and play with these and you want to get a little fancy, but you don't have to get super fancy with your plots. But next week, we are going to take your stock tickers and we're going to build out the charts for the last 5 days. So you guys will be able to chart your favorite stocks over the last 5 days, label them appropriately, what the starting end dates are, start prices, that kind of stuff.
Okay.
So that's what we'll be covering on Tuesday, Thursday. This is using Matplotlib to build charts and graphs by hand. After that, we're going to go use Streamlit, which will do that dynamically and do it automatically for you. Right. So you got to learn the old school way because you may want to plot this out in certain ways. But then you can now say, okay, here's a nice dashboard framework on a website. Instead of you building these, saving them as PNG files, uploading them to a web server, that system will actually build them on the fly. Anybody got any questions on NumPy, SciPy? All right, one other thing to cover on that. If you come out here and look at NumPy versus SciPy, read through the differences that are in here. All right. In the SciPy documentation, again, be aware of being able to look through the user guide and that kind of information so you know how it works, know how NumPy works, and know what the difference is between the two. You will need that information for the quiz next week.
Is the Matplotlib documentation in the Blackboard? Or
It did not look like it was there, and I'm going to add it. So great question. That's it. That's it for today. So I'm gonna stop this recording.